Assalamualaikum. Hi guys. In this video, I'm going to teach you based on several examples how to write the electronic configuration either in form of SPDF notation or in form of orbital diagram. So let's go to the first example, example 6.0. What I'm going to ask you to write the electronic configuration for sulfur with 16 proton number in terms of SPDF notation. So how am I going to write it down? I'm going to follow based on Aufbau principle. So I'm going to write my symbol for sulfur, capital S, equals to 1s2, 2s2, 2p6, 3s2, 3p4. If you take a look here, all of these electrons made up 16. Next, example 7.0. I want you to write the electronic configuration for aluminium atom in terms of orbital diagram. So what I have here, I'm going to give my symbol for aluminium, capital A, small letter L. So if you are not really quick learner in order to write the orbital diagram straight away, so I suggest for you to write the electronic configuration in terms of SPDF notation first. So if I write down AL in SPDF notation, I will have 1s2, 2s2, 2p6, 3s2, 3p1. Hence, after that, I can construct based on 1s2, 2s2, and 3s2, I got one room. And for 2p6 and 3p1, I got 3 rooms. So we are going to write in terms of how many electrons fill in specific atomic orbitals. You will have this one as orbital diagram for aluminium atom. Now, if I upgrade my question, I want you to write the electronic configuration for Al3+. So you can see 3+ here means that 3 electrons are removed from outermost shell of aluminium atom. So the outermost shell for aluminium atom can be based on what you've learned so far. You can see that here is n equals to 1, here is n equals to 2, so here is n equals to 3. So n equals to 3 is the highest energy level where you have 3 electrons in the outermost shell. So I'm going to remove 3 electrons from here. What's left for SPDF notation for Al3+ is going to be 1s2, 2s2, 2p6. No more orbitals for 3s and 3p because it's empty already. So let's go to the next example. Example 8.0. What I have here is I want you to write the electronic configuration for calcium. So calcium got 20 electrons. So let's write the orbital diagram. So as I mentioned before, if you are not really quick person to write the orbital diagram straight away, I suggest for you to write the SPDF notation first. So I got Ca equals to 1s2, 2s2, follow the Aufbau principle, 2p6, 3s2, 3p6, 4s2. So we got 20 electrons right now. So from here, I'm going to write my rooms for specific orbitals in calcium. I will have this one as my orbital diagram. And all of these atomic orbitals are filled up with 2 electrons with opposite spin. Now, I'm going to upgrade my question. How about the electronic configuration for Ca2+? And I want you to write down as in SPDF notation. As we've learned so far, we are going to remove electrons from higher energy level. So as you see here, we got n equals to 1, n equals to 2, n equals to 3, and last one, n equals to 4. So n equals to 4 is the highest energy level with 2 electrons in 4s orbital. So I'm going to remove 2 electrons for Ca2+. So it's going to be removed from 4s orbital. So what's left for Ca2+ is going to be 1s2, 2s2, 2p6, 3s2, 3p6. This one. Let's go for the last example. I want you to write the electronic configuration for ferrum or iron with 26 electrons. So how about right now, write in SPDF notation first. So write the symbol for ferrum first. I will have 26 electrons until 3d6. So we have here the SPDF notation for ferrum at its ground state. Now, how about I want you to write the electronic configuration in the same SPDF notation, but right now for Fe3+. So now, please remember we are going to apply what we've learned so far. Hopefully you still remember when you fill in the electron based on Aufbau principle, you fill in 4s dahulu, barulah 3d. So you got 4s2 and the leftover adalah 3d6. But at this point, 4s is much more higher energy level compared to 3d. Kerana apabila dia sudah diisi dengan elektron, dia akan repel. As you see here, sudah diisi 2 elektron dalam 4s, it will repel to higher energy level. So maknanya kita akan remove daripada 4s dahulu. So if you take a look carefully, this is n equals to 1, n equals to 2, n equals to 3, and n equals to 4. And here you can see that 2 electrons in 4s orbital, tapi case sekarang kita nak remove 3 electrons. So we got one more left. We are going to remove from 3d orbital. So what's left will be Fe3+, 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5. Because we got 2 electrons removed from 4s and 1 electron removed from 3d. So this is how you want to write the electronic configuration based on specific atom or ions. I hope you've learned a lot from here. So hopefully you can try to do the tutorial questions to enhance your understanding. That's it for this video. I'll see you in the next one. Bye.